Okay, now we have reached to the second application of integration, which is volume. So the volume of the solid generated by revolving the region about the axis, okay, either x-axis or y-axis, between the graph of a continuous function and the x-axis from a to b, is v equals to integration from a to b pi y squared dx. Since this lesson is about to find the volume, so the formula itself, if you look carefully, it is similarly to the formula of the volume of the cylinder. Do you still remember the volume of cylinder? V equals to pi r squared h. So pi, yes, pi r squared, the radius, so the radius here is a y function. And then what? How about h? Height. Height is represented by the limits from a to b. This is your height. Okay, this is going to be your cylinder. Alright guys, rotated about the x-axis. So please memorize this formula. And then the same goes when the volume is rotating about the y-axis. So when we go here, so we see the formula is v, okay, integration from c to d pi x squared dy. Okay, so from these two formula, you just change, okay, the difference is only at the function. Y here means the function of, while the below here is a x, which is function of y. Or if I rewrite it back in a manner form, v equals to from c to d pi, which is constant, function of y with respect to y squared pi r squared. This one also, okay, you'll be getting the volume revolving on the y axis. Those are the formula. We go to the example 18. Find the volume of the solid form when the area bounded by y equals to 1 over x, y-axis y equals to 2 and y equals to 5, okay, is rotated about y-axis. Okay, please be careful, okay, under the question under application of integration. So this is volume, so what you must do first, state the formula, because I want to prevent you from doing any mistake, especially in the formula. This is volume, so just put here v equals to pi is a constant, so I just put in front. So since this is clearly about the y-axis, so I just put here dy because y-axis, and then the function here must be fy, and then don't forget this is to be squared. Okay, this volume is actually involved of a curve and the axis. So we're gonna first sketch the graph will be looks like. So y equals to 1 over x. So first let's sketch the axis first, axis y, x and y. Okay, for y 1 over x, okay, we change to the color of blue. Okay, next the line y equals to 2, so use purple color, y equals to 2. So around here, this one is a y equals to 2, and then y equals to 5. Y equals to 5, the green color. So around here, here is a y equals to 5. Okay, so this all are the curve, okay, involved in this sketching. Y equals to x, here is a y equals to 1 over x, y equals to 5, y equals to 2, and the y-axis. So here is the y-axis, here is the x-axis. So now we look where would be the region located. So it must be bounded by the all colors, okay, by blue, by the green, by the purple, and the red one, which is here. Okay, this is the shaded region. So this shaded region will be rotated about the y-axis, so not at the other place. Okay, so it will be rotated here. So just imagine how it will be formed, the volume. Okay, so now, okay, we find the volume. So volume equals to, so always put your pi in front here. From limit, okay, we know here is a 2 and here is a 5. So from 2 to 5, okay, of the function y to be squared later with respect to y, because it is rotated about the y-axis. So now the function y is a 1 over y. So I integrate this, change to index form for better integration. So y power of negative 2 dy, so equals y equals to negative 2, integrate, so we are getting negative 1 over y from 2 to 5. So subtract negative 1 over 5 minus negative 1 over 2, and your answer would be 3 over 10 pi unit cube. Example 19. Sketch the curve y squared equals to 12, okay, in the bracket 3 minus x in the first quadrant. Given that R is the area bounded by the axis, so be careful of the word axis here, okay, in the first quadrant. Okay, so how to sketch this, since this question asking us to sketch the graph. Okay, y squared equals to 12 3 minus x, so y equals to positive square root of 12 3 is a 36 minus 3x. Okay, so this graph is a positive square root graph with x is a negative here, so something like this, okay, negative x. Okay, please ignore the notification sound. Okay, so since the question tells us about the first quadrant, so on first quadrant, so when you find out the domain of this, okay, you'll get x must be less than 3. So I just simply sketch here 3, and then when you find the y interception, okay, it's going to be 6 when x equals to 0. So the graph, okay, will be sketched like this. Okay, here is your region R. Okay, your R is here. Okay, you may find out this 3 and 6, okay, through the x interception and y interception also. And then you must know the basic of the square root graph as I show you above here. Okay, so this is actually the sketching of the graph. So let's move to the question. Next question, find the volume of the solid of revolution. So the volume, yes, obtained by revolving the region R about the x-axis. Okay, be careful. Volume x-axis, you must have pi, you must have square, and dx. Okay, as I told you before. So this one, v equals to pi, don't forget to put your pi, and then this is since rotated about the x-axis, so dx, and then here must be fx, okay, squared. So v1, so v1 equals to pi, okay. So for the x-axis, okay, the lower limit is from 0 up to 3. So from 0 to 3 of this function fx squared, so we know fx is a 12 3 minus, okay, please don't get confused because this is y squared. So I just straight away put the function here, so dx, okay. So since 12 is a constant, so I could taking out the 12 here, 12 pi, then inside, okay, so 3 integrate is a 3x minus x is a x squared over 2 from 0 to 3, so equals to 12 pi, okay, so 3 minus 9, 3 squared over 2 minus 0. So what do we get here? So the volume is a 54 pi units cube, okay. Okay, next, B, volume of the solid of revolution obtained by revolving the region R about the y-axis. Haha, so be careful, still the volume by y-axis. Okay, so just take note here. So the volume would be pi, always remember pi. Okay, and then here would be our function y. Why? Because this one will be rotated about the y-axis. So we are using with respect to y, dy. Okay, and then the function also y must be in terms of y. Okay, so now v2 equals to pi. Okay, so the lower and upper limit. Here we look back to the graph from 0 to 6. Okay, this one is rotated about the y-axis, so we are taking the limit at the y-axis, so from 0 to 6. So how about the function? So I have already transformed in the terms of y only, so it becomes 3 minus y squared over 12 with respect to y. So how do I get this? So from the original, okay, original we have y squared equals to 12, 3 minus x, so 3 minus x equals to y squared over 12, then x equals to 3 minus y squared over function y. Okay, so let's get started. We must expand the function first, squared, before we integrate. We will expand them first, 0 to 6. So we are getting here 9 minus 6y squared over 12 plus y power of 4 divided by 144 respect to y. So is the function has been simplified? Yes. Okay, so now we are integrating them, all of them. So pi 9 becomes 9y minus y to the power of 3 over 6. Okay, has been simplified, plus y power of 5 over 5 times 144, so it's 720 from 0 to 6. See, we are having here pi 144 over 5 minus 0, and then the final answer will be 144 pi over 5 units cubed. Okay, the last question, part C. Hence show that V1, okay, ratio to volume 2 must be equals to 15 to 8. So V1, V2. So what do we get for V1? Just now we get 55 pi, and then V2 144 over 5. So when we simplify two of them, so we are getting as stated 15 to 8. Okay, as shown as needed by the question. Okay, next lesson. Okay, we're going to find the volume of solids generated by revolving the region between two curves or a line and a curve. So simply I could say that to find the volume of a region between two functions, okay, whether the two functions are curves or those two functions, okay, maybe one line and then the other one is a curve. Firstly, let's have a look at when the volume is revolving about the x-axis. Okay, suppose that y1 equals to fx, and then the other function, which is y2 equals to gx, are non-negative continuous functions, such that, okay, that fx must be greater than gx for limit from a to b. So what do we do? Okay, let R be the region enclosed between these two functions, fx and gx, and the lines x equals to a and x equals to b. When this region is revolved about the x-axis, it generates a solid. Okay, so let's have a look at this graph. Okay, so on this sketching, okay, there are two functions. This one is a function fx, and then the other one is a function gx. So to find the volume, so we're going to use this formula, v equals integration of from a to b pi, so y1 squared minus y2 squared, which is fx squared minus gx squared, ab pi, and then inside this bracket is actually fx squared minus gx. So when you imagine this region, when it is rotated about this x-axis, so what would be the volume will be looks like? So it will looks like a donut. Okay, so you know what is donut? Okay, so that is a rotation of this region. So now we look when the region is revolved about the y-axis. Okay, suppose that x1 equals to fy function y and x2 is a function gy, a non-negative continuous function such that, okay, the same as above, which is fy is greater or larger than gy, okay, for a limit from c to d of y-axis. Right, so let R be the region enclosed between the graphs of these functions and the lines y equals to c and y equals to d. When this region is revolved about the y-axis, okay, so it will be rotated here at y-axis, it will generate a solid. Okay, let's look at this sketching. Okay, the same as above. This is the formula. The volume equals to pi. Okay, I put in front, so from c to d. So there are two functions here. Okay, so the function y squared minus gy, okay, all of this is to be squared, okay, with respect to y, because they are rotated at the y-axis. Okay, if you do realize in this function, okay, it is actually, okay, the function of, sorry, the volume of fy, okay, all of them, and then we subtract to the volume of gy. So as I said before, okay, so the sketching here, okay, the rotation, okay, is about the y-axis. So as I mentioned, okay, the region here, and I rotate, so the bigger function, which is fy, okay, the volume of fy, the first one, and then subtract the volume of gy. And then if we have a look at these two sketchings again, okay, if you do realize I didn't say anything about the upper function minus the lower function, and then for this part also I didn't mention anything about the most right minus the most left, okay, because in the volume, okay, we are doing them in the different way. What do we look is to get the function which is far away from the axis minus the other function, the other curve which is nearer to the axis. Okay, for this example, rotation about the x-axis, okay, the most far from the x-axis is a fx, so that's why we must put fx in the front minus, okay, the curve which is nearer to the x-axis is a gx, so minus gx here. All right, so the same thing happened when this region, okay, if you could imagine, what if I put this region below the x-axis? So the same thing, okay, we will be going to choose the curve which is far from the x-axis, and then we subtract with the curve which is nearer to the x-axis. The same goes here when the functions, these two functions, are rotated about the y-axis. Okay, we choose the curve which is far from the y-axis, and then going to subtract with the function which is nearer to the y-axis. Okay, next page, example 20. A region R is enclosed by the curve y equals to x squared minus 4, quadratic positive, and the line y equals to 2x minus 4. Sketch this graph and shade the region. Okay, first this is a positive quadratic, and then here is a linear positive. So we know that here is a graph quadratic which will intersect y-axis at -4. Okay, and then the roots of this function x squared minus 4 is x plus 2x minus 2, so -2 and 2. So I just simply, okay, -2, 2, okay, I just want to give the idea on how the graph, okay, would looks like. and then it cuts at -4 here, so something like this. Okay, how about this linear? This linear is a positive linear, so also cut at -4. So this both functions, okay, cuts at the same intersection point at y-axis, which is -4, and then 2, and then x-axis when y equals to 0. So 2x minus 4, x equals to 2. Here also hits at -4 and 2, and this linear also hits at -4 and 2. So let's sketch the graph, y-axis, and then I put the x-axis. Okay, so we know that it hits, okay, -4 and 2. So 1, 2, 3, 4. So somewhere here, okay, it's a -4. So 1, 2, 3. Here is 2. So the first graph quadratic. So we're going to use purple color. And then the other functions linear. So I choose the green one. -4, 2. Yes. So okay, so the region is quite small. So that is the region between these two curves, and then I have already shaded the region. So 2 and -4. Okay, if you can make it bigger, then make it bigger, because we are only focusing on this area only. I mean on this part only. Okay, we have done sketching the graph. So let's look at the next question. Find the volume of this solid generated when the region R is rotated through 2 pi radian about the x-axis. Okay, so what does it mean by this through 2 pi radian? Okay, 2 pi equals to 360 degrees. So it means that this region is rotated 360. Okay, about the x-axis, the volume. Okay, so the volume equals to, okay, don't forget your pi here, and then okay, the integration sign from the sketching, okay, at part A. So when we are rotating about the x-axis, so the limit that we are going to use is from 0 to 2. So the limits lower from 0 to upper limit 2. Okay, so we have two functions here. Okay, so which one is far from the x-axis? The purple one. Okay, the purple one is a quadratic. Okay, so the purple one is a quadratic. So x squared minus 4 squared minus, okay, the one which is nearer to the x-axis is the green one, which is linear. 2x minus 4 squared dx. Okay, so we have done. Okay, begin the most essential step. Okay, so you must do it correctly. Okay, because when you're wrong on this first step, then the rest will be wrong. So please be careful, okay, about the formula. Okay, so now first thing first, as usual, we are going to simplify the function first before we integrate. So here it becomes x power of 4 minus 8x squared plus 16 minus of, okay, we expand this to 4x squared. 4 to 8 times 2 is negative 16x plus 16. Okay, with respect to x, 0, 2. So x to the power 4. Okay, it is single. And then x squared, 8, 4 is negative 12. X squared minus plus 16x. So this is the only functions left. Okay, so now we are going to integrate all of this term. Pi x4 is a x power of 5 divided by 5 minus 12 x power of 3 divided by 3 plus 16x squared over 2 from 0 to 2. And then, okay, so you do the step of to put the upper limit and then subtract the lower limit. Minus 12 blah blah and blah. Okay, oh, so I should simplify this first. and then minus 0 0 0. Okay, so everything will be 0. So here is a 2 2, and then your answer is a 32 pi over 5 unit cube. Alright. Okay, example 21, topic integration. Okay, the final example. The diagram shows a region R in the first quadrant bounded by the curves. Okay, there are two curves, y equals 1 over 4, 4 minus x squared, and then the other one y2, okay, equals to 1 over 2, 4 minus x squared, and the y-axis, so there are 3, bounded by y1, y2, and y-axis. So calculate the volume of the solid form when R is rotated through 360 about the y-axis. So now it is rotated about the y-axis. Okay, so please remember the formula would be something like this: pi, okay, and then dy, because rotated about the y-axis. And then the function here also, okay, we're going to use function of y, not function x. First, okay, we change first the function given into the y, okay, terms. So first we have y equals to 1 over 4. So y equals to 1 over 4 minus x squared. So this function is in terms of x. So we are going to change into in terms of y. So 4y equals to 4 minus x squared. So x squared equals to 4 minus 4y. Okay, and then the other curve, y equals to 1 over 2, 4 minus x squared. So 2y equals to 4 minus x squared, and then x squared equals to 4 minus 2y. Okay, so I just let the function here to be x squared, okay, not x, because later, okay, this formula we're going to use x squared. So the volume, okay, when we look at this curve, okay, the region bounded by these two curves and the y-axis, okay, we know that the bigger function must subtract the smaller function. So in this case, the bigger one is from 0 to 2, and then will be subtract with the one from 0 to 1. Okay, so this is the formula. So volume equals to, okay, we are taking the first volume, the bigger one, which is from 0 to 2, okay, of the function 4 minus 2y, function y with respect to y, minus, okay, the smaller function pi from 0 to 1, 4 minus 4y with respect to y. Okay, so this is the formula. Okay, so next is nothing, we just simplify the function and then integrate. So there is no need to simplify. Okay, so straight away we integrate them all. So pi, so here is a 4y minus 2y squared over 2 is a y squared. So square bracket from 0 to 2 minus pi. Okay, so the same thing for y. So 4y squared over 2, 4 over 2 is 2 y squared, okay, from 0 to 1. So substitute pi. So here is a 4 2 minus 2 squared minus 0, and then the other one here pi also. So 4 1 minus 2 1 squared minus 0. So the answer is 2 pi unit